biology students. This is the next video, and last time we left off talking about ocean waves. We went from the swell to the surf zone to the swash zone, and the next thing we want to learn about is longshore currents and longshore drift. This picture here from your textbook shows you both. Remember, whenever we look at a overview or an aerial view, we're looking from the up above to down below, like a picture like this. North is always up, east is to the right, west is to the left, and south is down. Remember that. Here you can see the coastline. Here's the land, probably a beach, and this is the ocean in blue. You can see the waves, and represented by these wavy lines. The wind is represented by these is blowing out of the northeast towards the southwest, so that the waves are moving like this towards the shoreline. When that happens, those waves are going to be refracted. Let me spell that word for you. You might have heard of this word before, refracted. That means they're going to be deflected. They're going to be bent. Their direction is going to change. And what happens is that the waves are going to be refracted. If they're coming in from the northeast to the southwest, then they're going to be they have to be refracted parallel to the coast. And in this case, they'll be refracted to the south. So you're going to form a current that flows south due to, in this case, because of wind blowing in from the northeast. If you've ever been on the beach, you've experienced this. You ever notice that, I'm going to draw you a little picture here to remind you of, and if you haven't experienced it, if you haven't been on to a beach, then you haven't experienced it, but I'll show you what it's like. Let's say that this is the land, and this is the ocean over here. So this is the land. And you go, first I'll show you the longshore current. So let's say that the wind is blowing from the north towards the south. So these wavy lines represent wave crests moving to the south. Which way is the longshore current going to go? Do you think it'd be more likely to bend up towards the northwest or to the southeast? Well, since it's this angle here, it's easier for it to be deflected this way, right? So the longshore current is going to go towards the southeast. So what that means is if you're standing, if let's say there's a towel here, and your significant other is there, your husband or wife is there, or whoever, and then you go out into the water over here, and you look at your wife over here, and she's directly across from you, or your girlfriend or whoever, and then do you ever notice that like 15-30 minutes later, you're all the way over here? It's because the longshore current has carried you down the coast. That's and the drift, you drifted down coast. So if you could drift down coast, don't you think sand can drift down the coastline? Don't you think sand will sort of flow down the coast, in this case towards the southeast? I'm drawing another picture here. Okay, let's say the coast looks like this, and this is the land here. And this is the ocean over here. Let's say that the wave crests, the waves are coming out from the west to the east. Since they're going to hit at this angle, which way would the longshore current go? It would go this way, towards the northeast. So that means there's going to be a river of sand moving down the coast. One more picture. And this is a real picture here. This is the Southern California coastline. The winds blow in from the northwest. So here's your wave crest. Which way do you think the longshore current is going to go? Will it go south or north? Well, at this angle, it's obviously going to go south, right? So what that means is that sand is going to move to the south, or any object is going to move to the south. If you were up here in San Francisco and you put a bottle in the ocean, a couple months later, where's it going to be? It might make it all the way down to the Mexican border as it moves with the longshore drift. Okay, so before we go on further, let me show you a short two-minute video that might help you understand it. Here it is.
Hello everyone, today we're going to be looking at a coastal process. And this coastal process is called longshore drift. Now longshore drift is a type of movement of sediment or particles from one side of the beach to the other. And it's very important that we draw this diagram from a top-down perspective. Now the most important thing in this diagram, and the factor that actually causes longshore drift, is the wind direction, in this case the prevailing wind direction, which you can see labeled on the diagram. The prevailing wind direction will cause waves to move in exactly the same direction as the prevailing wind. And they will pick up particles from one side of the beach and they will move them up the beach due to the swash that rolls up the beach, and when they reach the top of the swash, they will roll back down the beach as backwash. Now when you're drawing this, it's very important the swash movement follows the wave direction, because that's the main thing that influences it. However, the backwash movement is influenced by gravity and therefore is vertically back down the beach. So this process continues over and over again every time a wave breaks on the beach, and eventually what will happen is that the particles will move from one side of the beach, in this case the left-hand side of the beach, to the right-hand side of the beach, following this movement of longshore drift. Thank you very much for watching, and have a really great day.
Okay, I thought that was pretty good. So what he's saying is that, let's again, here's the land and here's the ocean, and if the waves are, if the wind is blowing from the northwest to southeast, then it's going to move sand grains up the coast in the same direction as the wind, but gravity will carry it down. So basically, the sand is going to start to move down the coast, in this case towards the southeast. So same thing. That's a longshore drift. That's very important, as we'll see later on, because that river of sand is going to add sand to your beach if you own coastal property. And the more sand you have on your beach, the more your property is worth. Next thing we're going to learn about is these two terms: emergent coastline versus a submergent coastline. Okay, we need to know what the difference between an emergent and a submergent coastline is. First thing I'll tell you is that an emergent coastline for us in the United States is our west coast. We've got two submergent coastlines. I'm only talking about the lower 48 states, but we've got two submergent coastlines for the lower 48 states, and those are the Gulf of Mexico and the Atlantic coast. Okay, so first let's talk about an emergent coastline, and our example of that is the west coast. Okay, when you look at the west coast, you are going to, so make a list here. For the next 10 minutes, I'm going to be talking about the west coast. Make a list of all the things you see on the west coast, and you know that those are emergent coastline features. see, on images. Okay, our west coast looks like this. It's got headlands. These are you can see sea cliffs on these headlands, and then it has these bays where you have sand accumulate, and then it has headlands again here. So, bottom line is, our west coast looks like this. Well, actually, it goes south. Let me draw it again. Our west coast kind of looks like this, all the way from north of San Francisco down to the Mexican border. So this is the land, and here's the sea. Okay, these points of land that stick out into the ocean are called headlands. Head. Well, I'm not. It's too hard to write it in. Head, H-E-A-A, headlands. I mark with a capital H. Head, Headlands. And these are called bays. So here's a headland, a headland, a headland, a headland, a headland. In between the headlands, you have bays. And in the bays, you have beaches. Typical emergent coastline. Scotland's the same way. Scotland is a emergent coastline. So you got these beaches, and these are called pocket beaches. Like you have pockets in your pants, pocket beaches. So you got these pocket beaches, and here you got these headlands that stick into the ocean, and there's sea cliffs here. What happens is that the waves attack the headlands. The waves crash into the headlands, and the headlands are eroded. So they're broken down into smaller pieces of sand-sized particles, and those particles collect in the bays. So you got lots of mass wasting here. You got erosion here, and then you got sediments being deposited here in the bays. Where do you think the real estate's going to be more expensive in California, on the headlands or the bays? Obviously in the bays, because in the bays you have a nice sandy beach and no mass wasting. But over here in the headlands, you have sea cliff erosion, so it's continuously retreating on the headlands. So you're losing property. So the more expensive property is here in the bays on those pocket beaches. We're talking sometimes in the millions of dollars. Whereas you can get a cheap property here in Oceanside, for example, in California for $200,000, but it might only be 10 years before your condo falls into the ocean. So we're going to look at more features associated with the West Coast. The big thing is on the West Coast we have sea cliffs on those headlands. And so you can see the problem with buying property on these headlands is the waves crash into the headlands, and these sea cliffs get steeper and steeper and steeper. Mass wasting occurs. So these properties, you're buying them, but it's going to be worth less and less. That's why they're so cheap. You can see some more sea cliff erosion on headlands. So we've established that the waves crash into the headlands. And away from the bays, so that sand collects on these pocket beaches. Some other features associated with these on the with the west coast and an emergent coastline is that as the waves crash into the headlands, they make these little caves on both sides of the headlands. Let me show you what they look like. They're called sea caves. Okay, you can see here's a nice sea cave that has been punched into the side of the headlands as the waves crash into them. The surfers like to hang out here during low tide, and then when high tide comes in, they go catch a wave. So, going back to our picture, you form these little caves on both sides of the headlands as the waves crash into the headlands. You form caves. Eventually, what's going to happen, do you think? Eventually, as the waves keep crashing into the headlands, these caves will get deeper and deeper until they connect with each other. And then you'll make a sea arch. So as the coastline continues to erode, you form sea arches. Here you can see that this headland has been cut through sea caves, and then two sea caves are joined together and made a hole straight through the headland, and that's called a sea arch. This headland here, the two caves are connected, and there's your sea arch. You got a whole bunch of sea arches on the west coast. Why do you have sea cliffs on the west coast? Because the land is rising up more on the west coast faster than sea level is rising. Sea level is rising because of global warming, but the land out west is rising faster because of all the tectonic activity. Anyway, um, sea caves can join together, punching a hole straight through the headland, making a sea arch. Go swimming through those when you go out west. As the headland continues the road, what's going to happen next? Well, this part here is going to collapse, right? Eventually, as the waves keep crashing into this will collapse. And that gives you the next feature that we find on our west coast, and that's called a sea stack. So if a sea arch collapses, then you just form this stack of rock. This used to be connected to the mainland, but it's collapsed. The sea arch has collapsed, leaving behind a sea stack. Here you can see a headland that's been eroded by wave refraction. And here's your sea arch, and here, this used to be a sea arch, but now it's a sea stack. Be careful when you go out west and you go onto these sea stacks, because a lot of people they like to swim out to these sea stacks, or when the low tide goes out, there's a little sandy bridge between the sea stack and the mainland. And let me show you what we all West Coast people know that what this thing here is called a tombolo. So here you can see a sea stack connected to the mainland. And see the sandy beach that connects the mainland to the sea stack? That's called a tombolo. And out west, people know about when the low tide goes out, you can walk from the mainland to the sea stack. But be careful, because when the high tide comes in, the tombolo will be underwater, and if you're not a good swimmer, you can't get back to the mainland. You'll be trapped there until the next low tide goes in. I know, because I got my PhD at Southern Cal, and I had to work with the Baywatch people, and they would go around in these boats and have to rescue these people tourists, usually from the Midwest, who get stuck on the sea stack, and because they wanted to get back onto the mainland. It's not what you think. It's not like Baywatch, the TV show, Pamela Anderson. It's more like these hairy old men who are real grouchy. Anyway, here you can see those are common features: tombolos, sea arches, sea stacks, sea caves. Think of west coast emergent coastlines. Think of headlands and bays. That's a submergent coastline. Now let's take a look and see what I'm sorry, that's an emergent coastline. The west coast is an emergent coastline where you have sea stacks, sea arches, tombolos, headlands and bays. Now let's take a look and see what a submergent coastline looks like our east coast or our Gulf Coast. A submergent coastline is going to have barrier islands. Here you can see a typical East Coast coastline. You don't have those headlands and bays. You don't have those sea cliffs. It's submergent because sea level has risen with respect to the land. And so, since sea level has risen, back during the Ice Age, this mainland was connected to the bay to this barrier island, which is a strip of sand, a sandy beach along the coast. And then when sea level rose over the last 10,700 years, it flooded this area in, separating this part here from the mainland. And this part here that's been separated is called the barrier island. This here is called a lagoon. A lagoon. And here's the mainland. Let's take a look at an aerial view, typical East Coast submergent coastline. You got a sandy beach. Look at all the houses built here. This is prime real estate. If you go to the North Carolina coast, nice houses on the barrier island might cost you $350,000 to $600,000. If you're going to the Jersey Shore, they're more than $1 million, going up to $3 million. Here you can see the lagoon, and here's the open ocean over here. This is a submergent coastline. These sandy beaches are parallel to the coast. The waves break on these sandy beaches, so you have quiet water behind here in the lagoon. Low velocity, so that's where you're going to get mud accumulate. This will get preserved as shale. This will get preserved as sandstone later on in the rock record. These areas here behind the barrier island in the lagoon are where people dock their ships, because you got quiet water here. The waves aren't going to break in your berth, and you can anchor your ship here behind the barrier island, protected from the waves. Now I'm going to show you what an inlet is. Okay, first I'll show you a picture of it. Here you got a barrier island here and a barrier island here. And see this little body of water here entering into the lagoon? That's called an inlet. Here's a picture of an inlet. Here's your barrier island. Here's your lagoon. That's where people dock their ships. Here's the open ocean. So what is the inlet used for by people? Well, when the high tide comes in, people take their ship into the lagoon. And when the low tide goes out, they take the ship out of the lagoon and out into the open ocean. So this is a passageway where you could take your ship in and out of the lagoon, and it's called an inlet. When sand accumulates in these inlets, here you can see two inlets here, three inlets here actually. And here's the barrier island. If sand starts to accumulate here, then the U.S. Army Corps of Engineers will come here and dredge out the sand. to keep it clear so the shipping can go out in and out of the lagoon out into the open ocean. That's a typical East Coast situation, like Chesapeake Bay or Delaware Bay. You got barrier islands. You don't have headlands, and you don't have sea caves, and all those things we talked about before. Next thing we want to talk about, we talked about the fact that waves are real important in the ocean, and how they make the longshore current, and how waves change as they go from the deep ocean as swell, and they go into the surf zone, and then to the swash zone. But we haven't really talked about tides yet. So let's talk a little bit about the tides. If any of you have lived along the coast, you know what the tides are about. Let's say this is the beach over here, and here's the ocean out here. Well, every day the high tide comes in, marked by that H, and the low tide goes out. Here's your ocean out here. Here's a wave. So the high tide comes in, the low tide goes out. The high tide comes in again, and the low tide goes out. People who live along the coast know when the high tide's coming in and the low tide's going out. You have it on your phone, um, so you know exactly when the high tide's coming in. Now, when the high tide comes in, people will go on the pier and cast out their lines and go fishing. When the low tide goes out and all of this beach is exposed, that's when you go dig for clams and go for crabbing. So you can do a lot of fun things when the high tide comes in, low tide goes out. High tide comes in twice a day, and it goes out. A low tide goes out twice a day. So the distance between the vertical distance between high tide and low tide, marked by this X, is equal to the tidal range. The tidal range is measured in the United States in feet, but you can also measure it in meters. If you have a high tidal range, that means the ocean is going to come way inland and go way out. The tidal range is affected by a monthly cycle. It's called the lunar cycle. So what actually causes the tides? What causes the tides is the gravitational pull of the moon, mostly, and a little bit, and for a little bit from the sun, and to a lesser degree, the gravity of the sun. Let's take a look and see how that works. So we're going to talk about the monthly lunar cycle. When the moon is completely visible in the night sky, we call that a full moon. When the moon is dark, completely dark, we call it a new moon. We get one full moon every 29 days. We get one new moon every 29 days. Here you can see how this monthly cycle works. This is a new moon every 29 days and a full moon every 29 days. You get a first quarter moon every 29 days, which means half the moon is dark and half the moon is light. And you get a last quarter moon every 29 days, where the other side of the moon becomes visible and the other side is dark. So when let's see if I can get a nice picture to show how this works. So here you can see the moon. It's a lot closer to us than the sun. That's why even though the sun is much bigger, the moon exerts a greater gravitational pull on our oceans than the sun. So there's a bulge that points towards the moon of water. And on the opposite side of the planet, there's another bulge because there's less gravity over on this side, gravitational pull on this side. The Earth rotates on its axis once every 24 hours. So any location on the planet is going to go through each one of those bulges once a day. So, and since there's two bulges, you're going to get um, two high tides and two low tides a day. When the sun and the moon are lined up like they are here, you're going to get what we call spring tides. So what we're going to talk about next is spring tides and neap tides. Spring tides occur once a month, once every 30 days. Neap tides occur every 30 days. So when you have a spring tides, the moon and the sun are lined up, so you have your highest tidal range of the month. That means when you have every new moon and every full moon, you have your highest high tides of the month and your lowest low tides of the month. When you have neap tides, on the other hand, neap tides occur. Here's the sun, here's the moon. When the moon and the sun are at 90 degrees to the Earth, you get neap tides, and that occurs with last quarter or first quarter moons, where you have half the moon dark and half light. When that happens, you have your neap tides, which are your lowest tidal range of the month. In other words, you have your lowest high tides and your highest low tides of the month. There's less the ocean's not going to come in as much, as it's not going to go out as much when you have a first or you have a last quarter moon. Now let me ask you a question. When do you think there's a higher chance of um, flooding and mass wasting of the coastline occurring? During spring tides or neap tides? During spring tides, right? Because the ocean's going to come in more into the land during every full moon and every new moon. When do ocean storms hit the coastline? During the winter. So when's the most dangerous time of year where you're going to have houses being washed out into the ocean? It's during the winter, when an ocean storm comes in at the same time that you have spring tides. So spring tides combined with winter ocean storms are extremely dangerous along the coastline. To give you an example, in 1972, a combination of spring tides and winter ocean storms killed more than 300,000 people in Bangladesh. So neap tides and spring tides. We're gonna when you come back, we're gonna talk about ocean currents, and one of the founding fathers is a great man, and I really respect this man. And he helped discover ocean currents, and his name is Benjamin Franklin. And we'll talk about that in the next video.